October 7, 2025. The day began with anticipation. The European Space Agency had promised the first ever close-up images of 3I, ATLAS, the third interstellar object ever detected, now sweeping past Mars. Astronomers, journalists, and millions of watchers across the world waited for history to unfold. But when the images finally arrived, the reaction wasn't awe, it was confusion. Instead of a crisp, detailed portrait, ESA released a single, grainy frame. A faint blur. A dot lost in noise. Within hours, outrage spread across the internet. People demanded answers. How could the most advanced spacecraft around Mars return something that looked like it came from a backyard telescope? Why was NASA silent? Why were China and the UAE, both operating orbiters near Mars, not releasing their own data? For a brief moment, it felt like something had been hidden. ESA's technical team tried to explain. The CASIS camera aboard the ExoMars Trace gas orbiter was never built to capture distant comets. It was designed for sharp views of Martian terrain, not a tiny, icy body 30 million kilometers away. Each pixel, they said, covered about 340 kilometers at that distance. A comet nucleus just a few kilometers wide couldn't be resolved. No matter how perfectly you focused, physics would win, light would smear, signals would drown in noise. Still, the explanation didn't quiet the speculation. If ESA's billion-euro orbiter couldn't reveal more, where was NASA's Mars Reconnaissance Orbiter, with its HiRISE camera, capable of reading rover tracks from orbit? That's when the story grew darker. Because when people checked the mission logs, HiRISE had gone silent. The United States government shutdown, which began on October 1, had frozen all communications. Commands, data uploads, even public logs, everything was offline. The mission team couldn't even confirm whether their cameras had been pointed at 3I, ATLAS during the flyby. China's Tianwen-1 orbiter, equally silent. The UAE's Hope probe, quiet. No images. No statements. Nothing. For the first time in years, Mars, usually one of the most heavily monitored planets in the solar system, had gone dark. That silence became fuel. Online forums erupted. Amateur astronomers posted their own images, claiming to see a faint core, maybe even jets or a shadow of a tail. Some used AI upscaling, others deep stacking. They drew lines, arrows, even labeled the supposed energy plume. Others pushed back, calling it pareidolia, illusions born from overprocessed pixels. The debates turned vicious. One name stood out: Myat Trin, a well-known comet tracker from Melbourne. She published enhanced sequences showing strange symmetrical streaks, calling them non-random and directional, hints, she argued, of engineered control. Scientists dismissed the idea immediately. Yet her posts gained hundreds of thousands of views, and for many, her words became the spark of a conspiracy. While social media spiraled, a quiet discovery unfolded on Mars. At Jezero crater, Perseverance's navigation camera caught a faint streak moving across the Martian sky. Just one frame, barely visible, but perfectly aligned with 3I, Atlas's expected path. At 90 km per second, the comet would have crossed 54,000 kilometers in 10 minutes, the same length as the streak on the image. If it was real, it was proof that Perseverance had witnessed the comet's flyby. But a troubling detail lingered. If the streak came from a shorter exposure, it could mean something much closer, possibly in Mars orbit. Without the original image headers, no one could verify the exposure time. One missing number left everything uncertain. For scientists, that single frame became a riddle, a 54,000-kilometer question mark. Then, something even stranger emerged. The path of 3I, ATLAS across the Martian sky lined up, almost perfectly, with the coordinates of the famous 1977 WOW signal, the unexplained radio burst once thought to be a message from the stars. It was a coincidence too precise for some to ignore. To match that original signal strength from a transmitter hundreds of astronomical units away, you'd need the power of an entire power plant, focused in a single, narrow beam. Online analysts ran numbers, posted diagrams, compared hydrogen line frequencies. And yet, when they checked public radio observatory databases, there was nothing. No one had listened. No hydrogen line data, no raw spectrum files, no null results. Silence, optical and radio. As if the cosmos itself had gone quiet during the moment of closest contact. When 3I, ATLAS slipped behind the Sun on October 29, the mystery deepened. For nearly 40 hours, the comet was invisible to every ground-based telescope on Earth. The solar glare erased it completely. Astronomers could only run simulations, guessing whether it had survived the heat or shattered into fragments. The Galileo Project, a private research group searching for signs of non-natural technology, announced continuous radio monitoring throughout the blackout, but even they released no findings. And so, in the dark silence between fact and fear, speculation bloomed. Had 3I, ATLAS broken apart? Had it changed trajectory? Or was it doing something unnatural, while hidden behind the Sun? Early November brought no relief. Astronomers tracked its reappearance, but brightness readings were erratic. Some telescopes measured a faint increase, others a dimming curve. Orbital models shifted by fractions of a degree, small enough to dismiss, but large enough to raise eyebrows. Every variation became a new theory. Meanwhile, the JUICE spacecraft, far across the inner solar system, was preparing its instruments for a brief observation window. But the data, ESA warned, would not reach Earth until mid-2026. Too late for answers now. Even as new discoveries unfolded elsewhere, an unexpected near-Earth asteroid slipping inside GPS orbits undetected, a brightening outburst from Comet Lemon, and a strange approach by C-2025 R2SW. All eyes stayed fixed on 3I, Atlas. Because this was no ordinary comet. It came from beyond our Sun, carrying the chemistry of another star system. It passed Mars and vanished behind the Sun, and when it emerged, the numbers no longer matched perfectly. A blur, a silence, a streak, and a signal. That's all the world was given. And yet, in those fragments, something vast lingers, a whisper of movement across the interstellar dark. Whether natural or not, 3I, ATLAS has forced every agency, every observer, to face the limits of what we can see and what we can admit. Because sometimes, what's most unsettling about the universe isn't what's discovered, it's what's withheld.